So in the previous lesson, we looked at how to actually write a chemical formula for a particular chemical or a particular ionic substance. And in today's lesson, we're going to extend that knowledge, learn how to write a chemical equation to represent an entire ionic reaction rather than just an ionic substance. Ionic equations are just an extension to writing the chemical formulae for ionic compounds. So this is just expanding the knowledge where we wrote the chemical formula for a particular compound, but we didn't know anything about where it came from. So now we're going to fill in that gap of knowledge by saying, well, we're going to write an equation to represent where this final product actually came from. Again, it requires a really good knowledge of valency. If you don't know valency really well, your life will be much more difficult when you study chemistry. So it's a really good idea to know your valencies really well, or at least know how to find them on your periodic table. So unlike chemical formulae, instead of writing just the chemical formula of the product, the reactants are also written in to show you the process of how you go from A plus B to C. Now, what this is essentially it's a combination of balancing chemical equations, which I've done a full lesson on, as well as writing chemical formulae. Writing chemical formulae as in knowing how to write the product or knowing how to write the reactants. So this is the whole it's building up on the knowledge that we've learned before. Okay, so here's another example. So it's always better to study this in examples because it's hard to just tell you what to do. So we'll show you. So write down the chemical equation for the reaction between magnesium and oxygen. It's very similar to another question that we did. Instead of chlorine, we have oxygen. So first we have to determine the product. And this goes back to our chemical formulae topic. So the valence of Mg is 2+. The valence of O is 2-. And you can look that up on your periodic table, so don't be worried. You can look this up. So the lowest common multiple is 2. 2 times 1 and 2 times 1. Therefore, only one Mg atom and one O atom is needed per molecule of MgO. So the final product is Mg plus O gives you MgO. Okay, so that's our final product, MgO. Just remember that. We're going to just store this in our memory, sort of like a computer. We're going to store this in our memory for a second. Write down the reactants, and on the product side, the ions that they form. Now we're going to move away from this. This is our ideal case, but we're going to move away from it for a second. We only use this to figure out what this last bit was. Now we write down the reactants. Mg is a metal, but oxygen doesn't exist as O. It exists as O2, so we have to write that down. And then on this side, we're going to write down the ions that they actually form. So you can see Mg2+ is the ion that we form, and O2- is the other ion, the negative ion that we form. And there's 2 of them to balance the oxygens. So there's 2 oxygens here, but there's going to be 2 on this side as well. And now, now we're going to store this one for a second, and we'll come back to that. Now we balance the charges on both sides. So you can see here, the charge is 0, and the charge here is also 0. So the charge on the left-hand side is, well, obviously 0. Charge here is 2+. The charge here is 2- times 2, which gives you -4. So you've got 2+, -4 on this side, but we need 0. We need to be the same on both sides. So how can we turn 2+ into 4+? Well, we can multiply this one by 2. So we can put a 2 out the front here. So the net charge on the left-hand side is 0, while the charge on the right-hand side is 2-. Yes, it's 2-, that's correct. -4 plus 2 is -2. So we need 2 Mg ions on the right-hand side to balance the charge. So we multiply Mg2+ by 2. If we do that, we also have to multiply the Mg on the left by 2. So we've got to multiply this by 2, but then all of a sudden we've got 2 Mg on the right and only 1 on the left. So we'll just multiply this one by 2 as well. So this results in 2 Mg plus O2, 2 Mg2+ plus 2 O2, plus 2 O2-. And then we'll store that one just for our memory banks. Then we write the previous equation and equate to the final product. Okay, so we know the final product has to be this, MgO. So we got to turn these into MgO. So it's just this equation again, and these two combine to give you 2MgO. Okay? That's how we do it. You can see there's a lot of knowledge about valencies there, and you really need to know your valencies very well in order to do this quickly. So another way to view this is to use a Lewis dot diagram. So you can see here we've got Mg, and you remember the Lewis dot diagram is only the outer shell electrons. You've got 2 in the outer shell, and you've got oxygen, which has 6 in the outer shell. Those 2 electrons get given away. So now this one has a full outer shell, and this one has a full outer shell, so they're both happy. You can see this becomes, obviously if it's lost 2 electrons, it becomes 2+ ion. And this one has gained 2 electrons, as you can see, so it becomes 2 negative. And then it goes straight to MgO, because they're combined together. Okay? So that concludes today's lesson on writing ionic equations, or writing equations for ionic reactions. So hopefully you've learned how to utilize your valencies to write these equations, and hopefully you've extended your knowledge of chemical formulae to chemical equations. Okay.